Alright, here are the notes for section 6.2. 6.2 deals with counting elements in a Venn diagram, counting elements in a subset using a Venn diagram. We're introduced to Venn diagrams in the notes for 6.1, so let's go over a little bit of notation we'll need here in 6.2. Since we're counting the number of elements in a set, we're going to need notation to denote that. So if you have a little n with a set of parentheses and the set inside here, this means the number of elements in set A, for example. And then you can see this one down here. This means the number of elements in the union of A and B. Alright, so that brings us to a theorem. There's only one theorem for this section, but we're going to use it quite a bit. It's called the inclusion-exclusion principle, and it looks like this. If you wanted to find out the number of elements that are in the union of these two sets A and B, what you would do is take the number of elements in A, add it to the number of elements in B, but what's double counted is those elements that are in the intersection, so you're going to have to back those out. So that's the inclusion-exclusion principle. The number of elements in the union of two sets, you add the number of elements in the two sets, just add them together, but then you have to subtract the number of elements that they share that's in the intersection. Alright, let me jot down a quick example of this. Let's look at these two sets. Alright, let me give you a set A and a set B, and we'll illustrate this concept. Here's set A. 1, 3, 7, 8, 10, and 11. Alright, that's set B. Let me jot down B. Alright, B has the elements 2, 4, 6, 7, 9, and 10. Alright. So, actually, yeah, we're going to find quite a few things. Let's find, first of all, the number of elements in set A. It's pretty easy, right? We'll just count them up. 1, 2, 3, 4, 5, 6. Right? There are 6 elements in set A. There, all we did was count. Alright, for part B, let's find the number of elements in set B. 1, 2, 3. Alright, there's 6 there also. Those weren't too tough. Let me scooch back on C a little. Alright. Part C, yeah, let's figure out the number that's in a intersect B. If you recall, the elements that are in the intersection means the elements that they share, they have in common. So let's highlight these. What do they have in common? 7, right? 7's in both. And 10. Oops. 7 and 10 are the only two elements that these sets have in common. So that's 2. Alright, there's only 2 of those elements. The number that's in the intersection would be 2. Alright, let's actually use for part D that inclusion-exclusion principle, and we want to find the number that's in the union of the two. Alright, purely computation. We're not going to actually draw a Venn diagram, place all the elements in there and then count them. We are going to use this inclusion-exclusion principle up here from the previous page. The number of elements in set A is 6, plus if I add all of B, the numbers that are in B, notice that the 7 and the 10 were both counted twice, so that's why we have to subtract the number that's in the intersection, which was our answer for part C. So if I take 6 plus 6, I'll get 12, and subtract 2, the number that'll be in the union of the two sets is 10. I'll have 10 in the union there. I did have another example. Let me see if I have room to squeeze it in here. I think I do. Yeah, absolutely. Here, you'll do ones like this in the homework as well. Excuse me, I gotta sneeze. Okay, I'm okay. Alright, let's try this one. here we're going to be given some different information. Here they just flat out give us the number that's in A is 17. They give us the number that's in the union of the two sets. A union B is 40. They also give us the number that's in the intersection. It's 5. So what we have to do, we need to find the number that's in B. Alright, we're given everything else. I've got the number that's in A, I've got the number that's in my union, and the number that's in my intersection. So I'm looking for the number of elements in set B. I am going to write out this inclusion-exclusion principle. Here's my solution right here. Alright, that inclusion-exclusion principle is the number that's in the union is equal to the number that's in A plus the number of elements in set B minus the number that's in the intersection. Alright, so now let's plug in everything that we know. The number in A, whoops, let's start with the union over here. The union is 40. Right, the number that's in A is 17. I don't know the number of elements in set B, that's what I'm looking for. And they told us that 5 is in the intersection. So, yeah, I know everything except for the number of elements in B, and that's what I'm trying to solve for. So let's go ahead and solve this. 17 minus 5, I'll have a 12 over here. Alright, and if I want to find out the number of elements in set B, all I have to do is subtract the 12 from both sides. That gives me the number of elements in set B is 28. Right, so yeah, in the homework in WebAssign, you'll have to do one similar to this. They'll give you everything else, then you'll have to, solve for the number of elements that are in set B. But they'll give you enough information to figure that out. Okay, now, I had just enough room, that's good. Down here on this page, let's talk about Venn diagrams that have 3 sets. And I didn't want to rewrite all this or retype it. I actually cut and pasted it. So hopefully you can see it. Let's go through this example, which you'll do ones similar in WebAssign. Here it says, of the 19 fast food businesses on Valley Mills Drive, the number that have a drive-up window, outside seating, or a pay telephone is summarized as follows. So they give you all this data here. 15 have a drive-up window, 14 have outside seating, 5 have paid telephones, 10, I'm not going to read through all that, alright? And then we're going to look for all of these down here, right? We want to figure out A, B, C, D, and E. But what we have to do to start with is actually draw this Venn diagram. We've got to draw it to start with. So I just scroll down, so I'm going to need some space. This is going to be a Venn diagram with 3 sets. So far we've done Venn diagrams with 2 sets. Now this one's going to have 3. So you want to make a big Venn diagram. And I need 3 overlapping sets. Alright, when you're making a Venn diagram with 3 sets in it, just draw the circles kind of large, because all these little sections are going to have numbers in them, which represents the number of elements in each little subset. Alright, and let's label these. Let's say this circle, the first one I drew, represents the ones with drive up, with the drive up. Alright, this one over here, the second one I did, has outside seating. And the payphones will be down here. No one has payphones anymore. Alright, a pay telephone. Okay, so what you do to start filling this out, you start with the intersection of all 3 of them. That's the easiest thing to do, and then we're going to work our way out. Alright, it says that 2 businesses have all 3. So I'm going to put a 2 right in the middle where all 3 of them intersect. And we're going to work our way out. So it says 3 have a drive-up window and a payphone. So a drive-up window is here, pay telephone is here. So this little football-shaped region where they intersect, where 2 is part of it, but there's 2 elements here, but in this whole shape I need 3, so that means there's only 1 in that section. Alright, so if you add those 2 together, that's 3 that's in the intersection of those 2 sets. That's the main thing to see. If you can understand what we just did, then you can fill out all of the rest of this. See, we're just working our way backwards through this information. Alright, 4 have outside seating and a payphone. Outside seating and a payphone is this football-shaped region here. It's got a total 4. 2 are already accounted for, so that leaves 2 for that region. 10 have a drive-up window and outside seating. Drive-up window and outside seating is this football region shaped sticking up this way. 10 total, so if that's 2, that leaves me 8 for this section. Alright, I'll go a little backwards. 5 businesses have pay telephone, so in my big circle down here, all together I need a total 5. Those 5 are already accounted for, so there's nothing out here. You can put a 0 if you want to, but you don't have to. This 2 plus 2 plus 1, they're already in this section, in that circle for the pay telephones, and there's no more left floating out here. Alright, going backwards. 14 have outside seating. Alright, outside seating's over here. And I already have, what, 12. 8 and 2 is 10, plus 2 more is 12. So to get 14 total, that means there's 2 out there in that section. Alright, and let's back it up to that first bit of data. 15 have a drive-up window. Alright. 15 have a drive-up window, so how many here are already? That's 11, so I need a 4. Good. Alright, just like that. So, what we need to do now, it says, find the number of businesses that have Part A, a drive-up window and no outside seating. A drive-up window, that means all of these 14, or I'm sorry, that was 15 in here. A drive-up window and no outside seating. Outside seating, those 10 right there, the 8 and the 2, those are in the outside seating circle. So everything that's outside there, the 4 and the 1, which makes 5, that's 5 businesses. Have a drive-up window, but are outside of the ones that have the outside seating. Alright, so Part A, the answer is 5. Here's Part B. I'm going to stop this video at 15 minutes or at 13:15. Alright, Part B, a drive-up window and outside seating, but no payphone. Alright, a drive-up window and outside seating. Drive-up window and outside seating. That's the 8 and the 2. That's the intersection of the 2. Right, those 10 elements right here. But no pay telephone. These 2 have a pay telephone, so the 8 do not. Alright, those 10 elements inside this region both have drive-up window and outside seating. These 2 have a pay telephone, but those 8 do not. Alright, Part C says no pay telephone. Alright, that's everything outside of this circle. So that's the 8, the 2, and the 4, which is 14. Everything outside pay telephone. It's like the complement of the pay telephone. Alright, D, for less than a minute, only a drive-up window. Drive-up window. Alright, everything inside here has a drive-up window. The 8 and the 2 have outside seats. The 2 and the 1 here have pay telephone. So only these 4 right here are just the businesses that only have the drive-up window. Alright, and outside seating or a pay telephone. Or means union. Outside seating are all of these. Pay telephone, alright, were all of these. So, or is the union of all of those.